When you see a chat interface and ask a question, you're seeing the end product of a massive engineering effort. Most people imagine training an AI model as just running a big script on a cluster of GPUs. But in reality, a strong model is a system, not a single script. It involves building a massive, comprehensive blueprint for data, validation, and failure prevention before the first GPU even turns on. This is called the training foundation. It includes the corpus strategy, source inventory, cleaning rules, and evaluation benchmarks. These are the ingredients that actually decide how smart your model will be. Every dataset starts with a scope. For example, if you're building a coding assistant, your scope isn't just GitHub. It's high-quality Python, C++, and Go, specifically focused on systems architecture and modern best practices. Once the scope is defined, you create a source inventory. This is a technical ledger of every data source. You don't just dump files, you record their origin, their license, their token count, and their expected quality. Next come the cleaning rules. This is a series of automated filters that reject low-value data. We might use a green Python function code, reject record, to remove auto-generated code, empty files, or documents with too many non-ASCII characters. Finally, we define the validation sets. These are small, human-vetted samples of the most important data. They act as the compass. If the model starts losing performance on these specific files, we know our data strategy has failed. In the next lesson, we'll move from data to architecture, talking about tokenizers, transformers, and the actual training loop. Most people think training a frontier AI model means writing a training loop, pointing it at a dataset, and waiting. That is not what serious model building looks like. In reality, training a useful model means building an entire system around data, tokenization, validation, and failure prevention. Here is the first architecture to understand. Before we ever touch transformer code, we need a system made of source collection, cleaning, deduplication, corpus design, code-heavy examples, validation isolation, and early evaluation thinking. Key blueprint artifacts: corpus manifest.json, source inventory spreadsheet or YAML, rejected source ledger, held out validation manifest. Let's build the first real training foundation. We are not training the model yet. We are building the material the model will eventually learn from. Step 1. Define the real product goal. Step 2. Define what data types belong in the corpus. Step 3. Create a source inventory. Step 4. Write first-pass cleaning rules. Step 5. Preserve code with its surrounding context. Step 6. Define your first held-out validation sets now, not later. Why does all this matter before we even touch the model? Because next token learning can only compress what you feed it. If your corpus is shallow, duplicated, or polluted with junk, you are spending expensive compute teaching the model low-value patterns. The dataset is not just fuel, it is the teacher. The corpus is a distribution design problem. You are controlling domain density, code ratio, reasoning density, duplication, and contamination risk before training ever starts. In this lesson, we built the real starting point of a frontier model project, the data system. Next, we turn that training material into model-readable form by studying tokenization, validation surfaces, and the architecture decisions that turn a corpus into a real machine.